Alright, so the next group of compounds we want to discuss are known as aldehydes. So for this name, we want to underline the AL that aldehyde starts with. So aldehydes look like this. So if you remember, a ketone looks like this. So you see the difference in I'll label this ketone. The difference in an aldehyde and a ketone is that an aldehyde must have a carbon attached to the carbon that is double bonded to the oxygen. So if you think about what that means, if you have a lone carbon chain and you have a double bond in the middle to an oxygen, it has to be a ketone. So aldehyde groups have to be on the end of carbon chains. Okay? So you can't have an aldehyde group in the middle of a lone carbon chain. So that means that means naming them will be quite a bit easier because the location is often understood. Okay, so let's look at one. So the first step is recognizing that this is an aldehyde and not a ketone. Okay, so we see the hydrogen there, so it's an aldehyde. So I count the carbons, 1, 2, 3, 4. So I have BUT. There are only carbon-carbon single bonds, so I have an AN. So now I use the AL to denote that it's an aldehyde. So I have butanol here. I could put one butanol, okay, because the aldehyde group is on the first carbon, but there's nowhere else for it to be. Okay, aldehydes have to be on the end of a chain, so there's no need for me to put the one there. It's kind of understood. Let's look at another one. So hopefully we recognize this is an aldehyde. We count the number of carbons, 1, 2, 3, 4, 5. So I have pent. I have only carbon-carbon single bonds. So I have pentan. And it's an aldehyde, so I put an AL. Okay? So because it is an aldehyde, it has to be on the first carbon. I don't need a number there. Okay, so let's look at one more. So what is this one? Okay, so this molecule is actually still an aldehyde. Remember that carbon has 4 bonds, but if the fourth bond, or if one of the bonds is to a hydrogen, we don't necessarily have to show it. So you can imagine here, this carbon only has 1, 2, 3 bonds shown. So there's an inferred hydrogen right there. Okay, so just because you don't see that hydrogen there, you still have to think, is this an aldehyde? Okay, it would be the exact same situation as up here. I just didn't show the hydrogen explicitly down here. So same process. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7 carbons. Let's go ahead and make it 8. Okay, to make the problem a little easier. So I have OCT. I only have carbon-carbon single bonds, so I have AN, and it's an aldehyde, so I have AL. Okay, so I go back and double check myself, and I'm done. 1, 2, 3, 4, 5, 6, 7, 8. So I'm good to go octanol. Or I could say 1 octanol, but the 1 is understood in the situation. So let's go ahead and try one on our own in the opposite direction. Let's do propanol. Okay. So let's break apart what this name tells me. Prop is 3 carbons. AN is only carbon-carbon single bonds. AL tells me aldehyde. Notice there's no number here, so don't be stressed by that. If there's no number, that means it has to be understood where the aldehyde group is, and we know that aldehyde groups are always on the end of the chain. So it should be pretty simple here. So I draw a 3-carbon chain. I draw a carbon-oxygen double bond. So there is propanol. I could also do this. Okay, that's the exact same thing. Or I could have done this. Okay, that's also a correct answer. That's also a correct answer. Okay, so there's multiple ways to show many of these answers. As long as you can rotate it and flip it and make the structures be the same, they are identical answers there. Okay, so those are the basic rules for naming aldehydes.